All right. I'm gonna have to sit at the table for this one.
This is the Unit 3 exam to make sure I'm in the right one, right?
No, don't open the exam.
Don't open it?
No, it's not the
No,
exam.
'cause that's
It's the
the
group
exam.
quiz.
Huh? Oh, that's the wrong one then, huh?
It's the that's the final. That's the exam.
Oh, okay. Good thing you told me. I haven't timed out. Clarification there.
Get down.
Under lesson 19, right?
Lesson 20.
Okay, let me get to where I need to be.
I'm still opening, Eileen.
Week 12, right? No, week 11. Lesson 20. Okay, group meeting quiz. Right?
Yeah.
Correct. Lesson 20, group meeting quiz.
There it is.
I started a new job today, so I'm a little bit brain fried.
Oh, awesome. What job did you start?
I work in the GI lab now.
Rather than psych?
Yeah.
Awesome.
No
Hopefully
weekends
you
or
like it.
holidays.
Awesome.
Yeah.
That's really good.
Okay. Lot better environment.
So in the GI lab, so you're running tests and stuff, or?
So I assist the doctor in doing colonoscopies
Oh,
and endoscopies.
awesome.
Yeah, it's kind of cool. Like today I got to do a biopsy, and I don't know, I don't feel qualified for it, but
That's way cool. That's a pretty neat. It's pretty cool to watch on the TV as they're going down like an endoscopy or whatever into the stomach and to see everything, and it's pretty cool.
yeah, it is. I was surprised.
Well, good luck with that. That's awesome.
Thanks.
All right. Let's see here. Clear out some of my millions of windows open.
Oh my God. What hospital are you working at?
Hospital?
Mm-hmm. Or is it
It's called Logan Regional. It's an IHC hospital. I don't know if you guys, I guess that's a Utah thing. Intermountain
Intermountain
Healthcare.
Health. Yeah.
Yeah. Yeah, so Logan's a little town, so it's a little hospital here.
But Logan's beautiful.
It is. I love it. We're on the outskirts of Logan. We live in a little farm town, but.
All right. So question number 2. In an article in the Journal of Small Business Management, successful startup businesses in the United States and Korea were compared. One set of data compared educational levels, high school, or of people who manage successful startup companies in the United States. You want to determine if education level of managers of successful startup companies is independent of the country they are from. Which hypothesis test would be most appropriate for this analysis?
I said independent sample t-test, but I don't know.
You have to look at first that, remember they gave us this paper at the end of one of our lessons, I think it was 11, and it has a statistical test, and it says quantitative and categorical. So that's the first thing you have to look at. Is it numbers or is it values that are names and labels to decide which test it goes into? And that tool helped me.
So I put it to a test of two proportions. Is that wrong or is that right? Or is that, what did you put, Wanda?
I'm getting my paper out here.
What Wanda was saying, the test of two proportions makes the most sense.
That's kind of the way I look at it. If it's numbers, then I do a t-test. If it's like categorical, then I do then I look at if it's a one proportion or two proportion or a chi-square test of independence.
Okay.
But at the same time, it could be I was kind of between the test of I can't talk. The test of two proportions or a chi-squared test, because you also I kind of try to picture how the data would be represented, because wouldn't you have like high school, undergraduate, master's, or doctorate degree in, or would it just be, would that be?
This is how I look. As a startup business, you're looking at United States and Korea were compared, one set of data.
Mm-hmm.
And you want the difference between the two countries. I looked at it's categorical because there's no numbers. It's a names, and I put two sample independent. So I want you guys to look at that and see what you think.
You put what?
Well, it says here on the review questions 1 through 4.
What did you put a test of two proportions, or you put what answer did you put?
I put test of two sample independence.
The independent sample.
Well, I think it would be the proportion. It would be like either the test of two proportion or the chi-squared. That categorical, not quantitative.
Because on the T, you need one set of data, and we have two sets. And also on the Z test, you only need one set of data, not two. And this is two sets of data.
Right, but those are for quantitative. But this question is asking about categorical. So It would be the test of either the test of two proportions or the chi-squared test of independence. Because those ask about those talk about categorical things.
Do you see how like they could? It's hard to gauge just from this paragraph without seeing how they wrote out the data, because they could put on the side Korea and United States, and then at the top put high school, undergraduate, master's, and doctoral degrees, and then fill in the numbers in between. You know what I mean?
Yeah.
Or they could just put.
I don't remember how the chi independence. That was the last lesson, right?
Yep.
Yeah.
Oh, so that could be a big table. I mean? Yeah.
So it could have like the column at the top, column 1, 2, 3, 4 could be like all your different degrees, and then the rows could be, I don't know.
Oh, yeah.
What's your guys' gut? I'm kind of thinking now that it's a chi-squared test, and I did put test of two proportions, but I'm thinking it's a chi-squared test.
Okay, let's try it.
Okay. So 3. Man, I wish they did A, B, C, D, E to match the stinking homework prep thing we did. So annoying.
Yeah. So I can read this one. A human resource manager reported data from a recent involuntary reduction in force at her company. You are an attorney and want to determine if age discrimination was a factor. It is illegal to discriminate against employees because of the age. The company reported the number of employees in 2 groups, 40 years old or younger and over 40 years old. And over 40 years old. They also reported the number of employees in each group who were terminated. You want to determine if both age groups were treated equally. Which hypothesis test would be most appropriate? No. So I put test of 2 proportions, but
That's what I put.
okay, because age is categorical, right?
Correct.
Yes, age is categorical.
Okay. So number 4. I put.
I put nothing. I wasn't sure on this one.
I put test of 1 proportion. But I don't know. I think it's proportion because it's 48.5%. And we only used percentages when it came to proportions, right?
Yeah.
And so.
And it would have to, and it's not, you're not dealing with 2 proportions, so it would, I mean, I would agree with that.
Okay.
It's kind of weird how they wrote this question, though. Kind of threw me off a little bit.
Yeah, it's kind of confusing.
Okay.
You guys ready to move on to the next one, or?
Yep.
Okay, so it's the student project compared. The effectiveness of 2 different combination locks. So this one I put paired sample test. Because.
Okay.
I'm trying to go back and forth here, and sorry. So 4, I put D. You put what? Paired sample test?
Yeah.
I put independent sample test.
They put paired is because they each did, like each student did
Each
1 lock each time.
Oh, that's true. They
Would
each
you
did
regroup
one
on
of
things
the
here?
locks.
Would you start at 5 again?
We're on 5 right now.
We're on 5.
Okay, thank you, because I had to use the bathroom.
You're good.
Okay.
We're just starting 5.
So on 4, we put down the chi.
4, we put test of 1 proportion.
Okay.
So I don't know if it would be for number 5.
5, which is, yeah.
Yeah, you're right. It would be a paired sample T. I missed that little detail that each student they're
Doing 2 locks.
Yeah, they're working on each style of lock.
Okay.
So then those times would have to be paired. You couldn't mix and match them, right?
I'm sorry,
Right.
guys. I'm totally confused, being Dory here again. I'm back up at 2.
You're on, okay.
So number 2 was chi squared.
And 3,
3 was test of 2 proportions. And this is number 3, like on the quiz, not on the homework.
Yeah, that's what's confusing me because
Okay.
I'm trying to follow with my work I did. And number 4?
For test of 1 proportion.
Okay. Now let
And
me
then
get
5.
set up.
And 5, we said paired sample t-test.
Paired sample t-test. Okay.
So number 6 is to appraisers. When approving borrowers for mortgages, it is imperative that the appraisers value the same types of property consistently to make sure this is the case had recently valued. Which confidence interval would be most appropriate for this study?
I looked at that just because it's the same. Says it's the same types. Pray for me, Susan. Don't laugh at me. I have my daughter here.
This one I was kind of confused about because I don't know like if it would be paired, because if they're doing this, if like both appraisers are looking at the same property, so then it's paired.
That's what I put. I put a paired sample t-test just because, yeah, because you can't, if you change the property, then that changes their other values. Does that make sense?
Yeah.
But at the same time, it's quantitative, right? Because you're not dealing with you're dealing with the specific value or number that they chose. Correct? It wouldn't be categorical.
Right.
Okay.
So quantitative?
So it's so paired sample T or paired samples T confidence interval. So number 7, in a Wall Street Journal article on satisfaction with career paths, the percentage of psychology majors reporting that they were satisfied with their career paths were reported. Same data was also reported for accounting majors. He decided to construct a 95% confidence interval to see if the observed differences is significant. Which confidence interval would be most appropriate in the study?
I thought it was F, but I had a question mark by it.
That's what I put was F. But which one's
I did
F?
as well.
Because it's confidence interval for 2 proportions.
Yep.
Yeah.
That's what I put.
Me too. And did you guys like this next question?
Yeah. It seemed a little familiar. I don't know where I heard it from, but all right. So the Oreos, I put D. D as in dog.
Yes, I did too. The
independent sample T.
Yeah, I did as well.
I hope that's right, because that's what we put for our data collection that we submitted.
Right? Well,
so this is a confidence interval for 1 proportion.
No, 2.
Wait.
It's an independent sample T confidence interval.
Because it's got 2 sources of, it's our test.
Yeah.
Because we're testing 2 sources.
2, yeah.
And they're independent of one another, and they're not dependent. So number 9, which one of the following best defines the notion of the significance level of the hypothesis test? So basically define a level of significance.
So the probability of rejecting H of O, right?
Yeah, A.
Oh, wait.
I mean, sorry, probability of a type 1 error. B. That's what I put. I think I got to go back and forth here.
I put A. The probability of rejecting a null, whether it's true or not.
So I put that for 9.
Mine,
or for the next one, I mean.
I put so if you look in the index under level of significance, it says a number that is used to determine the p-value. A number that is used to determine if the p-value is small enough to reject the null hypothesis. This is also the probability of committing a type 1 error.
Perfect. Take it. Okay. So level of significance is a type 1. Does that make p-value a type 2?
So your level, no, the p-value, if you look in the index, states a p-value is the probability of obtaining a test statistic at least as extreme as the one that was actually observed, assuming the null hypothesis is true.
So it'd be the third one.
I concur. Okay. That was a previous test question.
Yeah.
So number 11.
Suppose you create a 95% confidence interval for a mean and get 10 and 20. You have been told to report this by saying something similar to, we are 95% confident that the true mean is between 10 and 20. Exactly what does this mean? I always get these things wrong. But
so there's
me too.
95.
I know C is wrong because it's a chance, so that's out. And so I thought
so there's a 95% chance that the true mean is between 10 and 20.
So C, right? I put C.
There's not a chance. There's no chance. That leads to question. It's either A or B. It's because of the sample mean between 10 and 20, or the data is between 10 and 20.
So what the question is what is that confidence interval telling you? It's suppose you're creating a 95% confidence interval for a mean and get 10 and 20. So first off, there's only one mean. There's one true mean, right?
Mm-hmm.
And that's saying that you're 95% confident that that one true mean is between 10 and 20. So on the actual quiz we're doing, 95% of the sample means are between 10 and 20. In my head, I say that can't be true because there's not more than one mean, right? But right. I guess there are more than one sample mean. That's not saying the true mean. Gosh, I hate math. I think it's D. But
I agree.
I don't know. I feel like I get these things wrong too all the time. But
1, 2. That's what I've always put for like these quizzes, like in tests and stuff, and I don't like. I don't know. I think I can't remember if I get them right or wrong. Like every time.
out of all of those, that's the only one that makes sense to me.
I agree.
So reiterate that.
So it's basically saying that there's a 95%, you're 95% confident, or that could, I feel like you could say it either way. You're 95% confident, or you have a 95% chance that the true mean is between 10 and 20. Because obviously B doesn't make any sense at all.
Yeah.
Um,
And it's
But
not
it says up here-
95% of the data.
yeah, we're not talking about all the data. We're talking about the mean.
The true mean.
Correct.
I'm pretty sure it's D.
I'm pretty sure it's D too.
Okay.
Because we're looking for the true mean.
Yeah.
Correct.
Thank you for letting me see the box.
So 12, what is the mean of distributions of the sample proportion? This question sucked. I don't understand what it's saying.
I put 30. But
Okay, I put 30 for 12 as well.
But I think I just did like 0.30 times 100.
Well, because I mean, yeah, because 30% of 100 would be 30.
Yeah.
Right?
And
But how do you find the standard deviation?
I have no idea. I feel like we did that at the very, very beginning.
Yeah.
Oh, isn't it mean over population? So 30 over 100?
It says here, the P is the mean. I said clarify. So I put P is 0.30 D. That's on 11.
Yeah.
Excuse me. That's on, oh, it's not giving us choices.
Isn't the
The
Oh, wait,
mean
what
is P. It's 0.30.
what is the equation for standard deviation? Is it something over the square root of n?
It's like P hat equals, I didn't write 0.30.
I'm not gonna lie, I spent like 25 minutes looking for this specific thing, and I couldn't really come up with a confident answer.
I couldn't get like 13 through 18, honestly.
I thought it was like something over the something over the square root of n.
I thought it was too, but then it's sample proportion, so isn't that the last lesson we just did?
Yeah. To get the standard deviation, it's P hat, or the standard deviation of P hat equals P times 1 minus P over n with the square root of all that.
Show me on your screen. Show me the.
I'm just looking back through the previous lessons. Let me write it down.
So yeah, write it down and show me. I'm having a hard time writing things. I'm getting dyslexic.
Can you see this equation at the top?
So that's the equation for standard deviation.
So that's P equals, what is that, N?
P hat equals, I can't read it and show it. P hat equals the square root of it's in lesson 16 under 3.2.2.
But what is P1? I can't even remember. This is like.
I know. I get like that too. I come back and I just forget everything, and I have to look up everything again.
Well, hold on. Let me think through this real quick.
Well, okay.
I thought this was easy when I was doing it, and then like going back to it for some reason I can't.
I know, right?
Piece it together. So is it P times 1 minus P over N?
P times 1 minus P over N, correct. With a square root over all that.
Yeah, okay.
So to get P hat, no, we should just be able to.
But is P hat the standard deviation?
No, that's to get the standard deviation of P hat. So if it's normally distributed, then P hat is equal to P. And then to find the standard deviation of P hat, it's P times 1 minus P over N square root. So if we have our P, we should just be, and we have, yeah, that should make sense. So
it'd be 0.30 times 1 minus 0.30, right?
Yeah, so it would be.
It's 0.30 brackets 1 minus 0.30 divided by 100.
Yes.
I don't have my calculator.
Dude, just use Desmos.com. It's the best thing ever.
I couldn't figure it out, like where to.
What's it called, Brian?
Desmos, DESMOS.com.
Is it a scientific calculator?
Yeah, if you just Google scientific calculator, it'll be one of the first things that pops up.
Okay. Oh, I see it now. I think I hit the wrong thing.
Holy smokes. Haha, that works. Cool. It's on there.
Feeling.
Yeah, right. I seriously spent way too much time trying to figure that out, and for some reason my brain could not figure it out. I don't know what I was thinking. Obviously wasn't. I was trying to go back to the very beginning to figure out how to do standard deviation, but I was forgetting that it was that we're
So did you
portions.
Did you get 0.046?
Correct.
Sweet.
And that's by, tell me the formula again, please.
You told us the formula, Wanda. You said it.
I know, but I'm Dory Bell here, okay?
Oh, okay. It's 0.30 times 1 minus 0.30.
Hold on
over
here.
100. And then you square root that all.
McKenna, did you do it in Desmos or did you do it on your calculator?
I did it in Desmos.
Yeah, it's awesome. Love it.
Yeah.
I love it because if you mess something up, you can just go back in and like change one little thing, or you can add something to it.
Oh, that's cool.
I must
Okay.
try your little calculator there.
All right, where's the probability? So now that we have a now we can find the z-score, right? Do we do the z-score?
Oh yeah. Okay, I see.
Because
Okay.
the equation for z, well,
Because then you can find the probability or
on the
the
probability applet.
applet. Okay.
But
What is the z-score? I don't think I wrote it down because I thought we could just do it all in the graph.
I know, right? So for one proportion,
Is that what I did? I put two sample z-test. Because you have an experimental group and you have a control group. So experimental group is P1 and control group is P2. But I think I'm missing the question because on 14, I'm looking at my test I did. This test is got me messed up. Father God, lead us. Lead us by the hand. I just feel dorified.
yeah, so
Well, isn't p hat equal to p?
Yep,
So-
Is that your probability?
what I have written in my notes for the z-score is p hat minus p
like 1 minus n.
p0 divided by the square root of p0, 1 minus p0 over n. But I'm trying to go back through here.
Oh, I remember. Okay, yeah.
Yeah,
But p hat and p are both 0.30, right?
Yep.
correct.
Did you guys do 14 already?
We're
We're on
on
14.
14. That's what we're trying to figure out, exactly how to figure 14 out.
Thank you. I'm on the same boat now.
So would the 0.25 then be your
Oh, that
Would
would
that
be
be-
your
Would that be in our
P-
applet? Because when it says probability, I think applet.
Yeah, so
Yeah.
we're trying to find the z-score is what we're trying to find so then we
To
can
plug
put that into the applet.
So is p hat 0.25 or is p 0.25?
Right? That's what I'm trying to think. So p hat is equal to x over n.
So that would be
30.
0.25 because that's the proportion. That's your sample proportion, right? Wait, I don't
think
know.
it's 0.25 minus 0.30 over that whole long thing. Let's see. Let's try that and see if we get an answer that's even in the.
Oh, part here, huh?
Perfect. So are you using? Wait.
So I'm going to go 0.25 minus 0.30 divided by square root of .30.
Breathe. Just swim. Okay, here we go.
I got negative 1.09. Oh, but that's not the. What's the z-score?
Oh, true. Thank you. I was like, dang it, it's not on there.
Negative 1.091. Let me shade to the left because it's less than.
Yeah, correct.
So I got 0.138.
Yeah, 0.138. Dadgummit, that's not on there. Oh yeah, it is. Sorry. Oh, cool.
It is?
Yeah, it's A, or it's yeah, it's on there.
Sweet. Okay, I don't have it open. I should get it open, but
I want to do this applet thing.
what?
What do you put in the applet?
An applet you put for the z-score is negative 1.090, and you shade to the left.
Do you understand how we found the z-score, Wanda?
Going back, I need the, like you said, p hat equals x over n.
Do you want me to write the equation?
Yes, please. I need the equation.
Okay, let me copy it real quick. Okay, here it is.
P hat minus p over square root of p minus 1 over n. Okay. And what numbers did you put in there?
So for p hat, it's the 0.25 that the equation gave us. And then our p's are 0.30. So anywhere you see a p, put a 0.30. And then our n is 100.
Thank you.
Mhm.
And then that will be our z-score.
Yeah.
Okay. Okay.
So 15 margin of error.
So this, okay, so this is the same equation. Okay, this is like now making sense.
I am just going to put that down there.
Can you remind me what the, do you know the margin of error equation? Oh, is it
Yeah, it's
p
gonna
times 1 minus p over n?
correct.
Okay.
Which
So
they didn't have us do this in the homework.
Oh.
So for P1, so the margin of error
Plus or minus.
would be Z times the P1 minus, or P1 1 minus P1 over N1 plus then the P2, right? It's going to be that whole, because you're doing P1 and P2 to get the margin of error.
Oh, yeah. Oh. I took
It's a
care
lot
of
longer.
last couple times, yeah.
I'm trying to look to see where I'm at again.
So it's a 95, so 1.96 times 38.
So wait, it's P times 1 minus P minus P2 times 1 minus P2?
If you can read my handwriting, it's that right there.
Okay. And it's times at the beginning, it's P1 times P2.
It's a plus underneath the square root.
Okay. Did you put this in a Excel sheet to figure it out?
You're gonna have to get your P hat 1 and your P hat 2.
So for my P hat 1, I got negative 0.003, and my P hat 2, I got 0.029.
My P hat 1, I got 0.039, and my P hat 2 got 0.026.
Did I put it in the wrong thing? I put a 2-sample z-test for proportions.
What did you put for your X1 and your N1?
X1 was 61 and N1 was 15363. X2 was 15 and N2 was 579.
And what did you put for your confidence interval? 0.95 and type
And
of.
then what type of test? P1 is less than P2.
I put not equal to.
Because it says in here. Where did I see the keyword? I gotta move this up. Oh, I'm not on that one yet. Question 14. If you look at the answers in your test, in our homework, review for exam 3, lesson 20 homework that we're supposed to do together here, but not outside the test. And 14, it gives you answers. In this quiz here, it doesn't give you answers.
Correct.
So when you look at your questions 14 through 18, on my 2-sample z-test proportions, I got negative 0.003, and on my P2, I got 0.029. So I don't know how you're getting your 0.039 and your 0.026.
I got those as well.
It's because I put the P1 is not equal to P2.
We'll try it with less than.
Well, and then it will give me the answer you got if I do that.
But if you look at the answers, on the test that they give you multiple choice,
correct,
your answer is not in there.
Oh, sorry. Are you looking? What did you get? Are you looking at the level of confidence or the P hat 1, P hat 2?
Let P1 be the true proportion of people who experience dizziness while taking the Acuprel. Let P2 be the true
Correct.
proportion of people who experience dizziness but did not take Acuprel. Create a 95% confidence interval for P1 minus P2.
So that is negative 0.003 and 0.029.
That's what I'm saying.
Correct. I'm not talking, sorry, for this question. The question
15?
we're trying to figure out, question 15 on the quiz we're doing, we're trying to compute the margin of error. That wasn't even a question that was in the review or in the homework that we were supposed to.
How you get the margin of error is you take the two numbers, 0.003 and 0.9, and subtract them and divide by 2.
Oh, that's for not this. That's for, I think it's independent test. It's not for this one is all I know. I can't remember which test that's for.
The equation that we're trying to solve for the margin of error under the confidence interval for two proportions is really long for me to say.
Give it to me. Can you email it to me?
But can you look? Do you look at this right here?
I can't see very good.
Can you see that?
It looks like
So
Z equals
Z times the square root of P hat 1 times 1 minus P hat 1 divided by N1.
Hold on. P hat 1 times P hat 2?
Hold on, let me see if I can, hold on, let me look here, just a second. Can I show you my screen?
Woohoo!
Give me 2 seconds. And share. Oh, we might be in business here, folks.
Thank you.
Oh, for crying out. Hold on. Just a second. Where? Oh no, did I? Great. Where's my? There. Okay. Let's try that. If this works, this will make way more sense for you, Wanda. Okay. Can you see my screen? Click on me down at the bottom.
Ah, we can.
Can you see the calculator? Okay,
Yeah.
so this is the equation that we're using.
So it's Z. But this bottom one there?
It's the bottom one, yep. Can you see my mouse?
Yeah.
I can see your mouse.
Can you see my Excel spreadsheet or just the Desmos calculator?
Just the
Just
calculator.
the Desmos.
Okay. So then 579. So that's the equation. Oh, for crying out loud.
This is cool. And it plus those two. Okay.
And I'm trying to get it. It didn't. It's not giving me a square root over the whole thing here.
Mm.
Do you see this? Do you see the equation?
Yes, sir, I do.
Okay.
So this is the equation, 1.96 with the square root over everything of 0.039 parentheses 1, hi dog, 0.039 brackets over 153 plus 0.026 brackets 1 minus 0.26 bracket over 579.
Yes, correct.
And that is how you get the mean error.
No, margin of error.
Phew.
Here's our answer.
Do we plus or minus, or do we add P1 minus P2? Oh, never mind.
No, that would be for our
The
confidence
lower
interval.
bound. Yeah, I'm sorry.
Yeah.
So it'd be 0.016.
0.016. And our
Hold
lower
on.
bound.
Okay.
I like how it takes it out to the nth.
Yeah. And so the lower bound would be
Negative 0.003.
Correct.
And the
And the
upper
other is 0.029.
correct.
Sometimes I hit the wrong button and put a comma and I get my answer wrong. So don't put commas in your answers.
Right.
okay.
Thank you, Ryan, for your extrapolating and for your teaching.
Yeah. No worries.
That'd be
That
nice
makes
to
it a
have.
lot easier than having to like explain it or try to write it and show it. So
Yeah, because
Yeah.
this 0.25 minus 0.30 is what now? That's the z?
that was to find our z-score, correct? That's the equation we used to find our z-score.
And that's what we put in.
And then that gave us the z-score here. And then we put that into the probability applet.
And then the probability applet gave us what?
Gave us 0.138. That was for number 14.
Okay.
So
Number-
oh, go ahead.
Oh, I was just moving on to 18, but
Yep, that's what I was gonna do too.
oh, so I got A.
A, yep.
I
Is it-
didn't.
Well, A, I don't know if it's the same.
I got P1 equals P2, and then P1 doesn't equal P2.
Yeah, you're right. The answers aren't the same.
No.
Okay.
But P1 doesn't equal P2 anyway. So I put P1 is less than P2.
But in this, for 18, it says perform a hypothesis test to see if the proportion of experimental group subjects who experience dizziness is different.
Different.
So it'd be not equal to.
Ah.
So it'd be A.
Those qualifying words.
Mm-hmm.
I had that highlighted too, but I thought difference meant. So to reiterate, the null P1 equals P2 and the ha is P1 does not equal P2.
Correct.
Yeah.
So that's A.
Correct.
Thank you.
Mm-hmm.
So then our test is the next question. Our test is, test statistic, I can't say it, equals negative 1.090. Is that the same? Or have we switched? 1 second.
It would be 1.48 or 458.
Oh, I'm
1.458.
Yeah. I was thinking it was still the one where we used the applet. We switched data.
And then p-value 0.145.
Mm-hmm. Yep. Well, so
I didn't get that. I got 0.146, but that was the closest one. Can you give me the formula for that, please?
It's in the Excel.
My Excel, which I did. 0.1. There it is. I got 1.458 in my Excel.
For your p-value?
Yeah, because the P is a Z.
Oh, you're looking at the Z. You're looking at. Wait, I don't know. Never mind.
The p-value is 0.145, and the Z is in zebra is 1.458.
Correct.
Correct. So
But
so 19, question 19 is 1.458.
hold on here because I am way behind. I'm looking at my other my work I've done.
These questions aren't even in the work we did, is it? I don't even think this is even any of this was in.
Let me recap then where I'm at. On question 19 in our current quiz, 1.458, 20, 0.145.
Correct.
Now question 21.
Correct. Okay.
So we failed to.
Fail. Mm-hmm. So it'd be A, or not A. It would be the last one. Sorry, that's tricky. Fail to.
Don't
accept.
do you reject or do you fail?
You fail to reject
because it's bigger than your level of significance.
Because the p-value is 0.145 is more than this level of significance, 0.05.
So you fail to reject it. Mm-hmm.
Which means insufficient evidence.
Correct.
Correct. Yeah.
So it means fail to reject.
So, so it would be the last one. So it'd be no, I failed to reject the null hypothesis. So meaning, is there sufficient evidence? No, there is not sufficient evidence, and I failed to reject because I failed to reject the null hypothesis.
That means you would. I get so confused on this.
Excuse me. So the way that they wrote the question or the answers in this question is kind of dumb because it's different than all the other questions that we've done previously.
So
they
yes, you would
reword it.
So yes, you fail to reject.
So is there sufficient evidence? No.
No,
No, there is insufficient evidence, correct?
correct.
So there's your first answer. So we're looking for yes or no. So it's no. And then why is it no? Why is it there insufficient evidence? Because we failed to reject the null hypothesis. Because the p-value was greater.
It's the opposite of what it should be.
Yeah.
Because the p-value was greater, so we had insufficient evidence, so then we failed to reject.
I failed to reject, and I did.
Yeah.
But how that's worded, I would have gotten it wrong.
Yeah, that's tricky because they changed it. Yeah. So it would be the last answer. No, I failed to reject the null hypothesis.
So 22.
Calculate the test statistic for the hypothesis test. Assume the requirements of the test are satisfied.
0.
6.580, yep.
Nope.
Let me find that data. So,
I put this in the chi-square test. This information.
Yeah. That would be correct. Did you get 6.580 for the test? I cannot say that word. Test statistic.
Statistic? Yeah, I did.
I got 6.579. So of course, rounding it up. I circled the answer 6.580.
Perfect.
But I want the formula because
that's just putting it into the Excel spreadsheet.
Yeah, there isn't a. Well, there is, but
there's no formula.
Not necessarily. The Excel spreadsheet does it all for us. So you just put those numbers into the Excel spreadsheet. So then our p-value is 0.086 or 87.
87, yeah.
And so on 22, you guys got 6.580.
You had it right. Yep.
Okay.
But your test statistic says on the chi-square test or square test 6.579. Is that correct, McKenna?
Yeah.
Mine says 6.580.
Oh, it does?
Yeah.
Mine says.
Oh, but on the I don't know.
Because mine
on like the homework.
Yeah, or on the actual Excel spreadsheet, mine says 6.579.
That's what mine says too.
But on the homework, it was rounded up to 6.580.
Oh. So
I don't know what it wants us to do for this one. So we'll put 6.580, and then if it's wrong, I'm assuming that it's the 0.579. So we'll see.
Okay. And then the p-value is 0.087.
Yep.
Hold on, I'm getting to where I need to get. Question. Question 24. Did you reject the null or not?
You failed to reject.
Yep, so no, we're not going to reject it.
Because the P is
greater
0.866 more than 0.05, which is a level of significance. So we fail to reject.
Correct.
Yep.
And thank you, Hannah, for helping me write all that down, because I look at that and I think, Hannah, help me with that.
No problem.
So it's D.
No, the p-value is less than 0.05.
No, the p-value is greater than 0.05.
Greater.
So it's no, the p-value is greater than 0.05. That is 1, 2, 3. That's D.
Correct.
Yep.
They are tricky.
So then 25 is we have insufficient evidence to say that every morning person is independent of age.
Correct.
Say that again and explain it.
So, when we fail to reject, we have insufficient evidence, right?
Uh-huh.
So I get the first part, and then the null hypothesis in these independent or not independent tests is always going to be is independent. That's always going to be your null, your HO. So we have insufficient evidence, and you state your null hypothesis, which is every morning person is independent of age. Computer's about to die. I'm going to go run and grab my charger before it dies.
Roger that. So Brian, let's go through each of these and go through it, okay?
From the beginning?
No, on 25. We have
Oh.
sufficient evidence to say that being a morning or evening person is not dependent of age.
So we can rule out automatically A and B, right? Because we know that there's insufficient evidence. So we know that it says
A and B says sufficient.
correct. So we can rule those out because we know our answer is going to have to say we have insufficient evidence.
Right.
Right. So we rule out A and B. And then between C and D, we're basically, do you ever watch the videos for each of the lessons?
Oh, I do all the time. I don't go 2 and 3 times over.
So whenever he says, the way he words it, it says, so we reject the null hypothesis, or so he'll say, if we reject, we have sufficient evidence, or if we do not reject or fail to reject, then we have insufficient evidence, and then state your null hypothesis. So we're just going to say we have insufficient evidence, and then we're just going to implant our null hypothesis into the question, which if you scroll up, it states our null hypothesis, which is being a morning or evening person is independent of age. So we have insufficient evidence to say that being a morning or evening person is independent of age. That's it. Does that make sense? So you can just say, is it sufficient or is it insufficient?
It's insufficient.
So insufficient, and then throw my null hypothesis on the end of it, and that'll give you the answer.
And so let me go back to that question. What question number was it?
That's just at the very beginning of this little group, right before question 22, where it gives us the information for all these questions. See where it says the null and
is different.
Yep. No. Here, let's do this. Hold on. All right, watch this. Okay. So look at my screen. So if we scroll up here, so right before question 22 right here, it gives us the information for the test or for these next 4 questions. Right there. That's our null hypothesis. So we're insufficient evidence, and then we're just basically putting that in word for word, and that's how we get the answer. Does that make sense?
Show me, highlight it.
I can't. It doesn't let me highlight it because it doesn't want you to copy and paste.
Being a morning person is independent, and being is not independent. So independent is the test. Thank you, Brian.
So,
Yeah.
sweet. Okay. Are you ready to move on? Or
yes,
Yep.
yes.
Yep. So
Okay.
26.
a recent book noted that only 20% of all investment managers outperform the Dow Jones Industrial Average over a 5-year period. A random sample of 200 investment managers that had graduated from one of the top 10 business programs in the country were followed over a 5-year period. 50 of these outperformed the Dow Jones Industrial Average. Let P be the true proportion of investment managers who graduated from one of the top 10 business programs who outperformed the Dow Jones over a 5-year period. I don't know how I got this, but I got 0.190 for the lower bound.
All right.
And I think I'm so sick of it that I may have been guessing.
I did not understand how to input the data into a one sample Z-test for a proportion.
Okay, so for this one, I put, so if you have, and you know that you have a sample of 200, so then I just did 20% of 200 was 40. So I put 40 over 200.
Go. What question
So-
are we on again?
I did that as well, but that gives you, then what do you put for your null hypothesis?
Yeah, that's the problem I didn't. Oh, and then I think I put,
Do you not have it up?
126. Sorry. No, I don't have it up. Or here, let me see. So I put.
But
And the null hypothesis is 0.20, right? No, that doesn't make sense. What did I do?
oh, I totally missed something in the question. So it would have to be 40 or 50 is your X, and your N is 200. 50 of these outperform the Dow. Let P be the true proportion of investment managers who graduated from one of the top 10 businesses who outperformed the Dow. I missed that 50 written
They didn't
out.
put a number, stinkers. Okay, so then.
God.
Okay, so then did you get 0.190?
For our
Lower bound.
Yes. Goodness. And
Okay.
the null hypothesis is 0.20.
Okay. Okay. So I
Hold
got
on
this.
here. I'm totally lost.
Okay, well, we can explain it because I spent another 30 minutes on this stinking question. I'm like, I'm missing a number somewhere. Oh, I totally, okay. So we're inputting all this data into the Excel spreadsheet, correct?
The one sample Z-test.
Yep,
Hold on. Let me get there.
one proportion spreadsheet. Oh, that feels better. Cool. I was like, I do not understand any of this. Why am I not understanding this? Because I feel like I should have it. And it was just missing one little number.
Well, this whole test was as I was doing it, it's like, okay, I've got this exam. But then this test comes and I'm like, I don't have this exam.
Right? When we did all the
When they
previous
put all the-
assignments, I was like, oh, this is pretty straightforward. And then they just totally reword everything and make you, they're trying to make us think. That's what it is. It drives me crazy. You shouldn't have to think, all right? You should be able to breeze through it. Okay, so Wanda, we put this into a one sample Z-test proportion.
Hold on. Let me get there.
Okay. And then just.
I'm still trying to.
And
just go with this here.
while you while you're figuring that out, McKenna, did you get n equals 1537
I had no idea how I did that.
for the next one?
Oh, does it give it to you? No, no, I got n equals 200. It's a 95%. Oh, awesome.
To reframe things, we're on question 26, right?
No, yeah.
I consider it a success that we made it an hour and a half without me dropping out, so that's good.
That's true. I got n equals 200.
For
I am
28?
lost.
For the population, yeah. Well, on my Excel.
Oh. Oh, yeah. Yeah. Sorry. Yeah. So we're inputting it into, I was asking you for 28 for the next one, but.
What is number question 26?
I thought you
So
said
26, so we're putting it into Excel, right? You have your Excel spreadsheet pulled up.
And that's going to be in which one?
The one proportion. I'm going to pull it up on my screen here and show you. Okay. Can you see this?
What? Okay, one proportion.
Oh. Yeah. So our X is 50. And,
X is 50.
And our N is 200. Do you see on my thing here?
It's 200. And our confidence level?
Is 95%.
And is it going to be greater than or less than?
Greater than.
Got that.
Because
And our null?
0.20.
Phew.
0.20 is the null.
correct. And the question is,
I don't remember what the
The
formula
lower bound
is.
would be 0.190.
correct.
Yep.
Because that's where you would get your confidence interval and the P in the first one.
Correct. And I guess it doesn't necessarily matter what you put for type of test, greater than, less than, or not equal to, because that's not going to change your confidence interval, because it doesn't really tell us greater than, less than, or not equal to. It's not going to affect your lower bound and upper bound.
It only affects your
P-value.
Z.
So now on question 28, the equation.
Hold on here. I'm going to save this before I whack out here. 28 would be, I didn't get 27 would be 0.310.
Yes.
It's good to be on the same page with you guys. Thank you.
No problem. 28 is the equation, is it Z over 2 times M squared, all of it squared?
So yeah, because we have our prior estimate of P, we have our P star, which is the P star is 0.2. So we have that. So we use the equation We use the n equals z star over m squared p star 1 minus p star. It's in the summary of lesson 17.
Okay.
I got, what did you get for this answer, McKenna?
I put a question mark by it. I didn't.
Okay.
I couldn't find the. But let me. We can talk quick.
You're good. I got 1537.
I will trust you and go with that.
I want to get this formula down.
Yep, I'm gonna pull it up for you right now. So if you look at my screen here, this is the equation that I put in. 1.96 over 0.02 squared times, and the equation for the actual equation is right there.
Oh.
So that's the equation right there that we use. I just highlighted. It's in the summary for lesson 17. And if we're not given a prior estimate of P or a P star, then we use the formula down below it.
Summary 5. Lesson.
That's lesson 17. The summary for lesson 17.
Okay. And can you flip back to your other screen where you put the square root of 0.30 brackets 1 minus 30 over?
Give me 2 seconds.
What did you get? I'm sorry for the answer.
I got that.
Oh, let me look. Sorry.
1537.
I got that as well.
Okay, let me do this again. So this is, one more time, please, Ryan.
What? The actual thing that we put, the
over 100 there. Thank you.
Sorry, no. Wait a second. That's the equation right there, Wanda, that we use to find n. That's what we put in. That's highlighted.
To find n.
Correct. Okay. Okay, so you guys good to go on?
Yep. So for the next one, I got a fifth one down.
Yep. So it's equal to, and then it's greater than, because which one performs better.
And then 30 is the first one.
Yep.
And then I got my I cannot say that. Test statistic is 1.768.
Yep.
Yep.
Value 0.039.
You got what?
For the p-value 0.039.
Oh,
I needed the equation on that.
That's just it's all that info's in your Excel spreadsheet.
for some reason I got 0.07.
It is. I see it. My p-value. Amazing.
But
You got what? Sorry, McKenna?
0.077. Oh no, but it's 0.039 when I don't know where I got that.
Yeah, because you might have.
I wonder if I changed the greater
It's
than.
right there.
Yeah, you put if you put not equal to, then it's 0.077.
Gotcha.
So it's greater
Okay.
than. Okay.
33.
So it's less than,
Reject.
so we reject it.
And there
So A. Right?
Right.
A, 33.
Yep.
Correct. Yes, I rejected the null hypothesis.
Mm-hmm. So then 34, the lower bound, I got 0.282.
Just 1 second.
Be on the homework.
$0.282, correct.
Sweet. Okay.
I don't see where that is. Is that in the standard deviation of the hypothesis test?
No, so on your homework, it's number 30.
Um,
The upper and lower bounds.
and the null hypothesis would be equal to 0.295.
Yeah.
Okay.
But are you talking about 35?
Correct. Well,
It's asking the upper bound.
No, in the Excel spreadsheet in the one sample t-test, it asks for putting in your confidence interval and then your null hypothesis and then the type of test.
Oh, I see. Okay. Yeah.
So what did you get for the upper bound was 0.293?
Yeah. And then my degrees of freedom were 99.
Me too.
And the test statistic was negative 2.803.
Yep. 2.8.
I'm way behind, guys.
You're good.
What number are you on, Wanda?
I'm on 32. 0.039.
Okay. Yep. And then 33 was the first one.
Yes.
Okay. 34 is 0.282. That's your question on the quiz is number 30. When it asks for the confidence interval, it's the smaller number.
34. 0.282.
Yep. And then so the next question is asking what's the bigger number on your confidence interval in 30.
What is the upper bound?
Yep. What did you get?
I have it blank.
Okay, so that's 0.293. And that's, you just get that out of Excel.
Am I on the wrong sheet again? Or do we round up?
Just Excel
What did
gives you 0.293. We got. Did you input the data from the spreadsheet, the blue dash scores,
Yes.
into your Excel?
Yes. We bring it up from the old time. It says bring up the old test.
What?
Yeah, where does it? What are you talking about?
Well, was it like in lesson 9 or something?
No.
Maybe because we're doing this is a one sample t-test.
Oh, yeah.
One sample t-test for means.
Correct.
Mhm.
And you just copy and paste all that data into your spreadsheet, and it gives you all the answers.
And we don't have to make any changes in it?
Not for this one, right?
Nope.
Oh, 136, what was the degrees of freedom?
99.
No points?
Nope.
I
test-
never know what to do, whether you put 0.000 or don't. I don't think it matters, maybe. I don't know. In Excel, it has 99.000, but let's see.
But it
I'm
says
not
for 3,
jealous.
usually it says to the third, doesn't it?
Yeah, and in this one, it doesn't say, so. And
So just put 99 and don't worry about it? Or do you point 0.000? I guess we'll see, won't we? I'm going to put 99.000.
Okay.
The test statistic is negative 2.803.
Yep. And then what'd you get for the p-value? I got 0.006.
My p-value is 0.996954069.
Did I? Oh, we lost Brian. I may have done it wrong.
But that's in the Excel.
I'm saying I may have done it wrong. I may have put like, I don't know what I. Hey, Brian. Oh, he's muted. I think your microphone's muted.
oh, and video is off. Sorry. What number are you guys on? 38.
38.
But yeah, what did you get for that?
0.006.
That's what I got as well.
That's not what I'm getting for my p-value in my t-test.
What do you have for your null hypothesis?
My null is 0.295.
And what are you putting for your type of test?
Greater than.
It's not equal to.
Ah.
Because
Those
it
all make the
says
difference, not equal to.
Says just up above, he wants to use this data to see his mean blue score, if his mean blue score differs from the mean blue scores of other leading translation software. So it's not equal to.
So then the next one is we have sufficient
Yep.
evidence to say the true mean is equal.
0.006?
Yes.
38.
Yep.
It's not equals to.
No, it would be because because we're rejecting the null.
Oh, so it would be not equal. It's different. No.
No, you're right. No, you're right. Because
Okay.
you say we have sufficient evidence, then you restate your null hypothesis.
Okay.
So the true mean is equal to, yeah, so it's D.
Okay. We still have 6 questions? Holy cow. Okay.
I know they added a ton in from the actual homework questions. So
Jeez.
Getting us ready for the test.
So for this one, my lower bound, I don't know if this is right. I got 8.728.
just sorry.
Me too.
Pulling up
I'm
the
sorry too.
spreadsheet.
I gotta get my
I-
spreadsheet open and stuff.
On the homework.
Lesson
So
6. Now I brought this sheet up, and where do I put the numbers? Do I put it in an Excel spreadsheet? This is when I got brain dead.
Yeah.
In doing this. So you have the AM heights and the PM types. So you're taking this information and putting it into what flow sheet?
A paired.
sample t-test. The only question I have, McKenna, is
A paired sample t-test?
Yep. You see my spreadsheet here, McKenna?
Let me see. Yeah.
So what do we put for our null hypothesis?
Let me look to see.
Because I'm getting my t-value of 22.446, which is not accurate. It can't be accurate, right?
So I got, but yeah, that doesn't seem right.
But it might, I don't know. Is that what you got too? You got 22.446?
I got.
Yeah, but I don't think
these. I don't need lunch of carbs.
I changed, I didn't change 0.
Paired sample.
You just left it at 0?
Yeah, and let me remember what. I left it at 0 because the null hypothesis, oh, what is the?
Yeah, I'm, then that must be right.
So it's trying to prove if it's different, right? And so the null hypothesis would be, I don't know.
Yeah.
But there is 0 change.
0 change, right? Okay.
Yeah.
Okay. So then our p-value would be 0.
Uh-huh.
Right. Okay. Because our test statistic is so large.
Yeah. And then our degrees of freedom.
It's 40.
I'm trying to get my map up here.
You're good. We're just kind of talking out loud.
I want to do this with you.
Yep, absolutely. We're kind of just
go
talking
over the answers so that we know how to explain it better.
Thank you.
And then our p-value is less than, so we reject. So it'd be C for 46 or 45?
Yeah, that's what I put.
Okay.
After a while, you did get kind of like, now which test is this going to be? And
I kind of feel like I just want to take the test tonight because everything is fresh in my brain from going through this.
I know. That's kind of how I am debating. Except for,
I don't know how to. I'm getting numbers here that aren't weird. That are weird.
So,
Confidence level in this paired sample T for means is 9.5. And what is the null hypothesis?
0.
0.
And the type of test?
Greater than. You can, if you look at my little window thing on my screen, and I have my Excel spreadsheet pulled up, so you can see everything on there and compare it to yours.
How did you get the differences?
It'll automatically calculate those for you when you put in the variable 1 and variable 2.
I think I did it wrong.
Because it says
Paired sample t-test for means.
says define differences as AM height minus PM height. So AM is going to be, your AM height is going to be variable 1. Your PM height is going to be variable 2. And then it'll automatically compute your differences.
Nope.
It didn't automatically compute your differences?
No, it did not.
Then at one point or another, you must have deleted the equations that are in your difference. You must have deleted something.
So my equation, look in your box and see what your equation is there for me, so I can put
Well,
my equation.
if I click on the difference, it gives, see this equation right here?
Where?
See my mouse?
No, I don't see your mouse.
You can't, do you see my mouse moving at all on my screen?
Click on your box for the differences.
I did. And look up above where it says FX. Am I on the right spreadsheet? Yeah. Oh, it doesn't. What the heck? Hold on. Let's do this. Now, does it pull it up? No. Weird.
What I put in the differences is I'm putting the formula in myself, since apparently I deleted it. I am not Excel savvy.
Yeah, you might have to re-download because it should automatically. You have all the. What do you have for under?
Let me just exit out of this then. I'm gonna close it.
Okay.
And don't save it, and I'm gonna go back in again. Pulling up the wrong sheets. Paired sample t-test. Doing this again. And thank you for being patient with me, guys.
Oh, you're good.
I appreciate your patience. And now I'm going to escape here. So I go,
Did you submit yours, McKenna?
Yeah. We missed the double stuff one. Did you submit yours too?
Yeah.
I think what it's asking though is like it's only asking of double stuff, so I'm wondering if it's independent simple.
I'm still on 40.
Yeah, sorry, we're here. We're here.
I still haven't got, it didn't put up a equation in my differences for my paired sample t-test for means. There's no equation in it.
Okay, you're gonna have to re-download it probably.
Can you show me what your equation is in that 8.5? Can you click on the cell and show me what the equation is?
For some reason, it's not showing
Letting you do
that.
it?
It just shows my Excel spreadsheet, and it's not showing my mouse. I don't understand why it's not. Maybe, hold on, let me see.
The equation is for what? Sorry.
For the Excel equation in the difference column, so it automatically computes it.
Yeah, mine's not computing.
You guys can't see my mouse?
No. I see it on 5.
Weird. I don't know why it's not doing that. Let me. You might just have to go into the textbook or into the assignments and re-download the whole thing. Because the only thing I'm guessing is that you went in on accident and hit and deleted it from the difference column.
Okay, so where at in the spreadsheet? What lesson?
Oh, I have no idea.
Here I can tell it. Go to the textbook. It doesn't matter what lesson, any of them.
Uh-huh.
Have you opened it? Let me know when you've opened it.
Okay, hold on. Let me get into there. It's wanting me to log back in because I've been out.
Oh, yeah.
I learn. Math. Individual preparation. Online checkbook. Okay.
Okay.
I'm in the textbook.
Okay, so on the very far left, the third thing down says data files. Do you see that?
It says on the top, it says lessons 1 through 24.
So now, look, the very, very far left of the page, as far as you can go, do you see that emblem that says BYU Idaho?
Yeah.
Okay, now go underneath that, still on the far left, there says main page, schedule.
Yes.
Click data file.
Okay.
So now you see the word data at the top underneath the lessons. There's those 2 sentences, and then there's in the red special note. Do you see that? Go to the end of that sentence, and it's a link that says Help Excel Tools.
Okay.
Click
on that. Okay.
And it's the units 2 and 4 file, the quantitative inference procedures. Click that. Okay. And then it's downloading it. So click on your download. And so now it'll open it for you.
Hold on, because mine's weird. It doesn't load like normals. Uh-huh.
So now that it's, do you know how to save as?
It's unit 2 and 4,
Yeah.
file, Excel, help tools.
I would just like file, save as, and name it something that you would know that it's the updated version. So maybe just say like the new.
I just save all mine on my desktop and then pull them up.
Yeah. Just a way to differentiate it from the other one that doesn't do the math for you. I have another class meeting that I need to go to.
You're good.
Okay. Are you guys good?
Mm-hmm.
If Brian can hang
Okay.
out with me, because I'm still trying to, it won't let me open it.
Okay. See you guys. Good luck with the test.
Okay, McGinnis, have a good one.
Thanks. You too.